Hello everyone, welcome back to our channel. Let's discuss the next topic, that is types of vibrations. In the first video we had a discussion on vibration. Vibration means what? The periodic displacement of atoms from their equilibrium positions. What we are observing, compressions and expansions in the molecule, because the bond between two atoms or two nuclei in a molecule is considered as a spring type. So because of the spring nature, what is happening? Compressions are takes place and expansions are takes place. Because of the compressions and expansions, what is happening? The position of the atoms are changing or not? The change in the position of atoms with respect to their equilibrium positions are commonly called as vibrations. So during the compressions and expansions, what kind of phenomena takes place? That is commonly called as types of vibration. So initially we are having the first type, that is commonly called as stretching vibrations. The second type is bending vibrations. So the vibrations are divided into how many types? Two types: stretching vibrations and bending vibrations. Already we know that the region of mid-air, what is the region? 625 centimeter inverse to 4000 centimeter inverse. Already we had a clear-cut discussion that this particular region of IR radiation, whenever interact with the unknown sample, we are going to get the proper information related to the functional group, right? So in this particular phenomena, what we are observing, the region from 625 to 1600 centimeter inverse, in between these two values, whatever the vibrations which are happening, because of the vibrations which we are going to get the frequency, those frequencies are due to the what? Bending vibrations. If the vibrations are takes place between the atoms, due to those vibrations, whatever the frequencies which we are getting, those frequencies are coming under what? 1600 to 4000 centimeter inverse. These kind of vibrations are commonly called as what? Stretching vibration. So the frequency of the stretching vibration is more than comparing with the frequency of bending vibrations. That you need to remember. What is the sentence? The frequency of the stretching vibration is higher than the frequency of the bending vibration. Why the stretching frequencies are higher than comparing with the bending frequencies, we will have a discussion. Okay. So simply here you need to remember this particular phenomena. Okay. Bending vibrations frequencies are observed in between 1600 to 625 centimeter inverse. Stretching vibrations are always observed between 4000 centimeter inverse to 1600 centimeter inverse. Okay. So whatever the organic functional groups which we are having, all the organic functional groups are having these kind of stretching vibrations. It means that what? The functional groups can be identified between the 1600 centimeter inverse to 4000 centimeter inverse. It means that what? Whatever the frequency which we are getting, if the frequency is in between 1600 to 4000 centimeter inverse, it means that what? That frequency is going to correspond to any one of the functional group. Okay, then what is the use of the frequencies which are coming in this particular region 625 to 1600? We will have a discussion on the later classes. Okay, simply remember, whatever the organic functional groups which we are having, those functional groups frequencies are always what? Stretching frequencies. Those are observed in between 1600 to 4000 centimeter inverse. Okay, now come to the first type, stretching vibration. Vibration means what? The distance between the nuclei or atoms are changing continuously. Compressions and expansions. Right? Because of the compressions and the expansions, if the bond length is changed between the atoms or the nuclei, then such type of vibrations are commonly called as what? Stretching vibrations. See this one, the change in bond length during the vibration. During the vibration, the distance is changing. Distance changing means what? Bond length is changing or not. If the distance is considered as a bond length, then we can say that those type of vibrations are commonly called as stretching vibrations. Simply, stretching vibrations are due to the change in bond length between the atoms or the nuclei. Done? The stretching vibrations are further divided into two types. What are those? Symmetric stretchings and asymmetric stretching vibrations. Two types of vibrations. Symmetric stretching vibration and asymmetric stretching vibration. Stretching vibration means what? Bond length should be changed. Okay? If the change in the bond length in equal manner, then that is called as symmetric stretching. The name itself indicates symmetric. See this one? This is the first bond and this is the second bond. In this case, what happens? Bond length is reduced or not? In this case, the bond length is increased or not? Here bond length reduced equally. Here bond length increased equally. That is a what? Systematic pattern or not? Symmetric pattern or not? That's why such kind of vibrations are commonly called as what? Symmetric stretching vibrations. Change in the bond length with equal manner is commonly called as symmetric stretching vibrations. Okay? The next one is what? Asymmetric stretching. The name itself indicates asymmetric. Not equal, unequal. Which one is unequal? Change in the bond length. If the change in bond length is unequal, then such type of vibrations are commonly called as what? Asymmetric stretching vibrations. See this one? This is the first bond, this is the second bond. See the first case? The first bond length is increased, second bond length is decreased. In the second case, what happens? The first bond length is decreased and the second bond length is increased. If the bond length is changing in this type, then such type of vibrations are commonly called as what? Asymmetric stretching vibrations. So this is the concept of what? Stretching vibrations. So stretching vibrations means what? During the vibration, if the bond length is changed, such type of vibrations are called as what? Stretching vibrations. The stretching vibrations are divided into how many types? Two types. What are those? Symmetric stretching vibrations and the asymmetric stretching vibrations. Symmetric stretching vibration means in a stretching vibration. Why? Because it is a part of the stretching vibration or not. So in a stretching vibration, if the bond length changes in an equal manner, then such type of vibrations are called as symmetric stretching vibrations. In case of asymmetric stretching, in stretching vibrations, if the bond length changes with unequal manner, then such type of vibrations are commonly called as what? Asymmetric stretching vibrations. Right? Now, during the vibration, what we are getting? The change in the frequency or not? Right? So, see the point. Asymmetric stretching frequencies are always larger than the symmetric stretching frequencies. Why? Because there is a lot of variation in the change in the bond length. That's why the asymmetric stretching frequencies are higher than the symmetric stretching frequencies. Okay. So, here due to the stretching we are getting two things. Symmetric stretching frequencies and asymmetric stretching frequencies. The asymmetric stretching frequencies values are higher than the symmetric stretching frequencies. That's why always we are having the data, that data related to only asymmetric stretching values. In the textbooks, we are observing always asymmetric stretching values for the identification of the different kinds of the organic functional groups. Okay, we are focusing on the what? Asymmetric stretching frequencies, right? Generally, we will represent gamma asymmetric. These kind of values we are getting. Okay, now come to the next one. This is what? Bending vibration. Second type of vibrations in IR spectroscopy is what? Bending vibrations. The name itself indicates we have a spring. If the spring is subjected to bending, what will happen? You have a spring. If the spring is subjected to bending, what happens? The change in bond angle takes place or not? That is commonly called as bending vibration. In a particular vibration, if you observe the change in bond angle, such type of vibrations are commonly called as what? Bending vibrations. Now you can understand why the bending frequencies are lesser than the stretching frequencies. In the stretching frequencies, what we are changing? Bond length. In order to change the length of the bond, we need to supply more amount of energy. But in case of the bending, we need not to supply more amount of energy. Little amount of energy is required to bend the spring, to bend the bonds. That's why the required frequencies are lesser in bending, higher in stretching. Okay. Similar to the stretching vibrations, the bending vibrations are also how many types? Two types. What are those? In plane bending vibrations and out of plane bending vibrations. Bending vibrations are divided into two types. In plane bending vibrations and out of plane bending vibrations. So these vibrations are further divided into two types. See this one. In plane bending vibrations are scissoring and rocking. Out of plane bending vibrations are twisting and wagging. The name itself indicates in plane, means during the bending vibration what happens? The bond angle will be changed or not? If the change in the bond angle in a in plane manner, then such kind of vibrations are called as what? In plane bending vibrations. If the change in the bond angle due to the out of plane orientation of the atoms or the nuclei, such type of vibrations are called as out of plane bending vibrations. Let us check the possibilities. How many ways we can in plane change in the bond angle or out of plane change in the bond angle? See the first one. Here, see this one. Suppose we are having X bond angle between the two bonds. If you see the change, what we are observing? These two B atoms are moving in the opposite direction or not? So because of the moving in the opposite direction, what is happening? The bond angle is going to be changed or not? The X value will be changed or not? This is the first criteria. What is the first criteria? The attached atoms are moving in plane. That is on board only. In plane, opposite moment. Here see this one. In plane, opposite movement. Here bond angle increased. Here bond angle decreased. Such type of bending vibrations are commonly called as scissoring vibrations. What is the definition? Change in the bond angle with in plane movement of atoms of the nuclei with opposite direction. Bond angle should be changed. How? By the opposite direction of the moment of the atoms. Then that is commonly called as scissoring. So to this, what is the opposite one? Here atoms are moving in the opposite direction. Here what should happen? One atom followed by another. It means what? Both the atoms are moving in the same direction. See this one? This is the AB bond. This is the X value. So Now the B atom is moving upwards. This B atom is also moving. So one is followed by another or not, but in plane only. Here see this one. This B atom is coming downwards. This is also coming downwards. Because of that reason, what is happening? The bond angle is changing or not? That is also one followed by another or not. So such type of vibrations are commonly called as rocking vibrations. Okay. The in-plane bending vibrations are two types: scissoring and rocking. In scissoring, what is happening? The bond angle is changing by the opposite moment of the atoms. In case of rocking, what happens? The change in the bond angle due to the same directional moment of the atoms. This is the concept. Now come to the next one. Out of the plane bending vibrations. It means that what? Above the plane or below the plane. Okay. See this one, twisting and wagging. In twisting, what we are observing? We have two atoms, B, B. B plus and B minus. What is the meaning? B plus means, assume that this is B1 and B2. B1, B2, B1, B2, B1, B2, B1, B2, B1, B2, B1, B2, B1, B2. So here what we are observing, the B1 atom is going to above the plane. This is this one what? Above the plane. The B2 atom is below the plane. So one atom is above the plane, another atom below the plane. Because of that reason, bond angle is changing. In the second case, what is happening? The B1 atom is below the plane, the B2 atom is above the plane. In this situation also bond angle will be changed. Then such type of vibrations are commonly called as what? Twisting vibrations. Next one is what? Wagging. In case of wagging, what we are observing? Both the atoms are above the plane. Both the atoms are below the plane. The bond angle is going to be changed by change in the moment of atoms above the plane. Here, change in the moment of atoms below the plane. So such type of vibrations are commonly called as what? Bending vibrations. So bending vibrations are total how many types? 1, 2, 3 and 4. 4 types bending vibrations. 2 in plane and 2 out of the plane. Stretching vibrations are 2 types, symmetric and asymmetric. Okay, among all the type of vibrations, the frequencies which we are having related to the asymmetric stretching, these stretching frequency values are very, very, very important. Okay, that's why in the next video we are going to have a clear-cut discussion on what are the asymmetric stretching frequencies of each and every organic functional group, along with some symmetric also, some bending also. So in case of the IR spectroscopy, the main important portion is the remembering the frequency values. Most of the cases, asymmetric stretching frequency values of the corresponding functional groups. You need to remember. Then only you will be able to do the combined problems. Okay. So in the next video, I am going to give the complete values of all the functional groups. So from the day 1, you need to start remembering each and every value. Just we need to identify or remember the regions, not a particular value. 1620, 1630, it's not like that. We need to have a range. 1620 to 1680 means that is corresponds to which organic functional group, right? So 1700 to 1750, that corresponds to which organic functional group, stretching frequency. In that way we need to remember. So next video is very, very, very important video. So you need to have the special focus on the next video. Okay.